Hello everyone, welcome back to my channel. Today we will start a new topic, that is complex variable. First of all, we will understand few definition and then we will start with our question part. So first definition we will understand, that is what is complex function. If for each value of complex variable, means z is equal to x plus iy, complex variable in given region R, we have one and more value of w, then w is said to be complex function of z. And we can write this w, which is equal to f of z, or we can write w is equal to u plus iv, where u and v are real function of z. So what we are trying to say, if for each value of z in given region R we have one and more value of w, then w is said to be complex function of z, and we can write w is equal to f of z, which is equal to u plus iv, where u and v are real function of z. For example, like w which is equal to z square, w which is equal to z raised to power half, w which is equal to z raised to power 1 by 6, and so on. You can write more value like w which is equal to cos z, cos hyperbolic z. Okay, so for each value of that complex variable z in a given region R, we have one and more value of w is said to be complex function of z, and we can write this w which is equal to f of z. F of z means function of z, and z we can write x plus iy, where x and y is real number, right? For w we can write u plus iv, where u and v are real function of z. Okay, so there are two kinds of complex function. Okay, two kinds of complex function. First is a single valued function. Okay, single valued function, and another is multiple valued function. Multiple valued function. Okay, what is single valued function? For each value of z, there are corresponding only one value of w. Okay, there corresponding only one value of w, then w is said to be single valued function. For example, w which is equal to z square. Okay, what is multiple valued function? For each value of z, there may be more value of w. Okay, then w is said to be multiple valued function. If there are two and more than two value of w for each value of z, then it is called multiple valued function. For example, w is equal to root z, this is multiple valued function, or w which is equal to power 1 by 3, that is also multiple valued function. Okay, now we will understand exponential function of complex variable. Okay, so let's see. Exponential function of complex variable. we are already familiar with exponential function when x is a real number. So when x is a real number, we can write e raised to power x, which is equal to 1 plus x. The series is x square upon factorial 2 plus x cube upon factorial 3 plus x raised to power 4 upon factorial 4, and so on. Okay. Now if z is any complex number, so e raised to power z we will write as 1 plus z plus z square upon factorial 2 plus z cube upon factorial 3 plus z raised to power 4 upon factorial 4, and so on. What is z? Z we can write x plus iy, or z you can write e raised to power I theta multiplied with r, or you can write x plus iy in Cartesian coordinate system. Okay, now if I am writing e raised to power z, so it means it is e raised to power x plus iy, and we can written as e raised to power x dot e raised to power iy, because same base is there. And now what is e raised to power iy? Okay, so e raised to power iy means cos y plus I sin y. Okay, you know that e raised to power I theta, which is equal to cos theta plus I sin theta. Okay, so e raised to power z means e raised to power x cos y plus I sin y. You do no need to remember this, you just learn this process. E raised to power z, which is equal to e raised to power x plus iy. We separate the power, so e raised to power z dot e raised to power iy, sorry, e raised to power x dot e raised to power iy. And what is e raised to power iy? This is equal to cos y plus I sin y. That is e raised to power z is not 0 for any value of z. Okay, e raised to power z is not 0 for any value of z. And the next point is e raised to power z bar is equal to e raised to power z whole bar. E raised to power iy, which is equal to cos y plus I sin y. Okay, and e raised to power minus iy, it will be cos y minus I sin y. Okay, so you can write sin y by adding this, by subtracting this equation number 1 and 2, 1 minus 2, we will get sin y, and this is equal to e raised to power iy minus e raised to power minus iy divided by 2y. Okay, and when we add this to equation number 1 and 2, so what we will get? E raised to power iy plus e raised to power minus iy, this is equal to 2 cos y, or e raised to power iy plus e raised to power minus iy divided by 2, which is equal to cos y. So this is a relation of exponential and cos function, and similarly sine function. Cos theta plus I sin theta power n is equal to cos n theta plus I sin n theta, where n is rational number. Okay, this is also important theorem. And now we will understand some definition of limit, continuity and differentiability, because for analytical function we want that definition. You might learn in your previously 11th and 12th syllabus, but again we will revise definition of limit, continuity and differentiability, and then we will understand what is analytic function. First definition is limit of complex number of complex function. Okay, a function w which is equal to f of z is said to tend to limit L as z approaches to a point z0 if for real number epsilon we can find positive real number delta such that f of z minus that limit L is less than epsilon and z minus z0 is less than delta. Okay, so we can write z tends to z0 limit f of z which is equal to L. Okay, once again, limit of complex function. A function w is equal to f of z is said to tends to limit L as z approaches to point z0 for real number epsilon such that we can find a positive real number delta f of z minus L less than epsilon, z minus z0 less than delta, and we can write z tends to z0 limit f of z which is equal to L. Next definition, continuity of f of z. A function w which is equal to function of z is said to be continuous at z is equal to z0 if z tends to z0 limit f of z which is equal to f of z. Okay, a function w is equal to f of z is said to be continuous at point z is equal to z0 if z tends to z0 limit f of z which is equal to f of z0. So we can add one more thing in this, that is f of z is said to be continuous in any region R of z plane if it is continuous at every point in that region or in region R. Okay, so what is continuity? A function f of z is said to be continuous at z is equal to z0 if z tends to z0 limit f of z which is equal to f of z0. F of z is said to be continuous at any region R of z plane if it is continuous at every point in that region. Okay, next definition is differentiability. W which is equal to function of z be a single valued function single valued function of z which is equal to x plus iy, then w which is equal to function of z, then dw upon dz, or you can write as f dash of z is equal to del z tends to 0 limit f of z plus del z minus f of z divided by del z. Okay, provided that limit is exist. Next definition is neighborhood. A delta neighborhood of point z0 is the set of all points of z such that z minus z0 is less than delta. Okay, delta is any positive number and we have to find z minus z0 is less than delta. Okay, so now we will understand the next definition, that is analytic function. Analytic function. A function f of z is said to be analytic at point z0 if f is differentiable not only z0 but at every point of some neighborhood of z0. Okay, f of z is said to be analytic at point z0, at any point z0 if f is differentiable not only that point but every point in neighborhood of z0. Okay, the second definition we can write: a function is analytic into a function f of z is analytic in domain D if it is analytic everywhere. At every point. Okay, this is analytical function definition. Now we will check necessary and sufficient condition. Necessary and sufficient condition for an analytic function. Necessary and sufficient condition for an analytical function. Okay, so first we will check what is necessary condition. if function w, which is equal to function of z, is analytic in region R, then del u by del x is equal to del v by del y, and del v by del x is equal to minus of del u by del y. Okay, or you can say ux, which is equal to vy, and uy, which is equal to minus of vx. Okay, this condition is, or this equation is known as CR equation, or you can say that Cauchy-Riemann equation. Okay, and the next is sufficient condition. Sufficient condition means a complex function w is equal to function of z is analytic in region R if ux, which is equal to vy, uy, which is equal to minus of vx, this is first condition, and second condition you can say that ux, uy, vx and vy are continuous. Okay. So what is necessary and sufficient condition? First, any analytical function satisfied CR equation, and ux, uy, vx, vy are continuous. Okay, so now let's see some question which is based on analytic function. Let's take a question on this. Question number 1. Show that f of z, which is equal to e raised to power x cos y plus I sin y is analytic function. Okay, so what we will do, first of all we will convert f of z as e raised to power x cos y I sin y. We will write real part separately and imaginary part separately. Okay, so now what is real part? Real part is u, so f of z or w you can write as u plus iv. So what is u here? U is equal to e raised to power x cos y, and v is equal to e raised to power x sin y. Okay, to show that this function is analytical function, we will show the necessary condition, that is we will satisfy the CR equation. Okay, so what is CR equation? CR equation means ux, which is equal to vy, and uy, which is equal to minus of vx. We will show this condition and we will say that if all partial derivative are continuous, then this function is analytic function. Okay, so first of all we will find this ux, uy, vx and vy. Okay, partially differentiation of u with respect to x and y, partially differentiation v with respect to x and y. Okay, so u is equal to e raised to power x cos y, so ux partially differentiation with respect to x is equal to e raised to power x cos y, because when we are doing partially differentiation with respect to x, our y variable is constant, so cos y is a constant, and e raised to power x differentiation is e raised to power x. And what is uy? So uy means partially differentiation with respect to y, where x is a constant, so e raised to power x is constant, and differentiation of cos y is minus sin y. Okay, so your uy value is equal to e raised to power x sin y with negative sign. So this is my uy and this is my ux. Now v, okay, so v is equal to e raised to power x sin y. Now what is vx? Means partially differentiation with respect to x, so this will be e raised to power x sin y. Okay, and what is vy? So e raised to power x and differentiation of sin y. Okay, differentiation of sin y is cos y. So now what we have to check? We have to check that ux is equal to vy. Is it true? Let's see. So ux, okay, and value of ux is this. Ux is equal to vy. Yes, it is correct. Ux is equal to vy and uy value is this minus of e raised to power x sin y. This is my uy, which is equal to minus of vx. Correct? Yes, this is correct. So we can say that CR equation satisfied and partial derivative are continuous. Partial derivative are continuous. Then f of z is analytic function. Okay, you just satisfied the condition ux is equal to vy, uy which is equal to minus of vx. If it is satisfied and derivatives are continuous, then we can say that f of z is analytical function. Okay, so let's see this question again. Show that f of z which is equal to e raised to power x cos y plus I sin y is analytic. What is your step number 1? Step number 1 is separating real and imaginary part. Okay, so this is your step number 1, where you separate real and imaginary part. What is your step number 2? That is, you have to write CR equation. What is your step number 3? So step number 3 is you have to find all partial derivative, that is ux, uy, vx and vy. And step number 4, that is you have to check that your partial derivatives are satisfied, that is CR equation is satisfied or not. And step number 5, that is f of z is analytic function. Okay, so thank you so much. I hope you understand the topic and you like the video. If you like the video, please subscribe to the channel. Thank you so much.